Okay, before we start trapezoid rule today, I do want to start with the warm-up question. What I would like you to do, please, is copy this table down into your notes. You will see some problems like this in your My Math Lab homework and maybe on a test. So the next test is next Thursday and Friday before spring break. So copy down this table. We are given 5 x values. X equals 2, 3, 5, 8, and 13. And f of x equals 1, 4, negative 2, 3, and 6. So just copy down the table. This is an old AP test question. These are what the free response questions look like. A lot of them have multiple parts, like 3, 4, 5 parts. So the AP test may only have like 4 free response questions, but they each have like 4 or 5 parts. So they take a little bit while. I'm concerned with, we're going to look at C. It says use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral of f from 2 to 13. Show the work that leads to your answer. So after you copy down this table, I just want you to write down this integral, the integral of f from 2 to 13. We're going to approximate the area under the curve, f, from 2 to 13, using the data points given in the table.
We're just copying the table.
Just copy the table and then write down the integral of f from 2 to 13, and we're going to write is approximately equals 2. Okay, so it does tell us that we're going to use a left Riemann sum. Get my pen. Put that other way. Use a left Riemann sum with how many rectangles?
With 9.
With subintervals. That's all it says. It doesn't tell you how many to use. It just says with subintervals. If it doesn't tell us how many subintervals to use, how many do we want to use to get us the most accurate approximation? As many as we can. Okay, looking at that table of 5 x values, what's the most number of rectangles I can use? 4. The rectangles are the spaces in between the x's, right? So if you have 5 x's, you have 1, 2, 3, 4 rectangles. So we do want to use 4 rectangles. That will get us a more accurate approximation. So then my next question is, what is my delta x? What's the change in x? Look at the x's.
11 over 4.
How'd you get 11 over 4?
Because 13 minus 2, I mean, we're doing 4 rectangles.
Okay, so if you're using your delta x formula, b minus a over n, 13 minus 2 is 11, divided by 4 is 11 over 4. But if you add 11 fourths plus 2, what do you get? 19 fourths. Is that an x value that we have in the table? I can't use that delta x. I don't have, that's not what I have given in the table. I can only use those 5 data points. So then what the freak do you use?
No clue.
Can you please tell us?
So I just want you to look at the tell me and tell me what is the change in x.
1, 2, 3, 5. It's
Oh!
Oh, is it exponential?
It's not equal. Please write that down.
You can do that?
The delta x is not equal. The delta x is not equal. The x's are not changing by the same amount each time, right? To get from 2 to 3, that's plus 1. To get from 3 to 5, that's plus 2. 5 to 8, 3. 8 to 13, that's 5. That's not even quadratic. Because the change of the change is not constant.
I don't know how to say it, but I'm going to spell it.
What? Fibonacci. Yeah, those are, it reminds you of Fibonacci. That's 1, 1, 2, 3, 5. Yeah. Okay, so if the delta x is not equal, I can't just do delta x times the heights of those 4 rectangles. How am I going to calculate the areas of these 4 rectangles if all the delta x's are different? What?
Yeah, it's like
Plug what into the calculator?
The table.
No. What? Yes, you're going to have to just calculate the area of each rectangle separately and add those areas together because the widths are not the same, so we can't factor that out, okay? So we're going to approximate this by calculating the area of the rectangle separately. So the first rectangle goes from 2 to 3. What's the width?
1.
1. What's the height of the first rectangle?
3, 4.
4. My fault.
The height is the y value.
4.
3.
1.
Four, 4, 3, 1. What kind of Riemann sum are we doing? We're doing a left Riemann sum. So you look at the two y values. You're going to pick the one on the left. Wow.
There was one of the 3.
I'm glad we're doing this together. All right, so that's the area of the first rectangle. It's 1 by 1. Second rectangle goes from 3 to 5. What's the width? 2. Which y value am I using as the height?
4.
The one on the left. 4. Rectangle 3, what's the width?
3.
3. What's the height?
-2.
How can I have a height of -2? Now your function is dipping below, as we know. That gives me a negative integral, which is just going to cancel out with some of the positive areas. That's okay. Plus rectangle 4, what's the width?
5.
And the height?
3.
We're using the 3. So because we're doing a left Riemann sum, we're not going to use that 6, right? Okay, multiply and add. Find your total area. I'll walk through a lap. Multiply and add.
Times 1 plus 8
It doesn't take that long.
equals
18.
minus 6. 2.
9 minus 6.
What's your unit?
21.
What's your unit? 1
1
plus 8 minus 6 plus 15 equals 18 units squared.
Ryder, why did you say 17? That what you said his name.
No names. Alright, so I wanted to make sure I went over this problem with you because when you do your next homework assignment in my math lab, even though it's trapezoids, you're still going to have this idea where the delta x's are not equal. And unfortunately, if you come across this, and those of you taking the AP test, it probably will happen, they'll give you a table that's not equally spaced out. So then you just have to find the areas separately and add them together. It just takes a little bit more time, okay? All right, so if you want to start a new section in your notes, this is 5.5, the trapezoid rule or the trapezoidal rule. Please write down your title. Adela, go put your phone in your slot, please. I mean student. All students should have their phones in their slots. Do I need to count? Do I need to count? Is your phone up there? Okay. All right. Let's start with the first question. What is a trapezoid?
It's a trapezoid.
Please be very specific. We are literally doing this in geometry right now.
Part of a shape.
You never understood it.
Talk about it
I
in
just
pre-calc.
knew that if it looks like a shape that was missing, that was missing a part, that's a trapezoid. That's like
What's the definition of a trapezoid?
5-sided.
5-sided.
It looks like that.
Okay, what is that called?
Quadrilateral.
Okay, it's a quadrilateral. Good grief. It is a quadrilateral.
Polynomial.
A quadrilateral is a four-sided polygon.
One set of
Great.
parallel lines.
Yes, thank you. With one pair of parallel sides. If your quadrilateral has two pairs of parallel sides, what do we call that?
The rectangle.
Equilateral. I mean, not equilateral.
Call it a parallelogram. Does anybody know what you call a quadrilateral with no pairs of parallel sides?
Not a
A circle.
You know?
Miss Nelson.
It has a name.
You have all
Wait,
the
what is
answers.
It's called a trapezium.
We've never. Okay, we did not go over that.
You did. You probably some of you in Geometry K made a specific type of trapezium.
Was it kite?
A kite.
We didn't make one actually.
Oh, you didn't get to
We
make
didn't.
them?
We never made
Yeah.
one.
So a kite has no pairs of parallel sides. That
What
is
do
an
you mean?
example of a trapezium. Yes. So trapezoids. Can anyone name a type of trapezoid?
Right.
Right trapezoid.
Okay, a right trapezoid
An acute trapezoid.
has two right angles. Here's my pair of parallel sides, right? What other kinds of trapezoids are there? The one that most people think of when they think of trapezoid is this one. It's got two sides that are congruent. Kind of like a triangle with two sides that are congruent.
Triangular.
Isosceles. This is an isosceles trapezoid where the two legs are congruent to each other. The bases are the ones that are parallel to each other, right? And then of course you just have the weird trapezoids that are not right and are not isosceles, but they still have one pair of parallel sides. Okay, how do you find the area of a trapezoid? Anybody remember this formula? There are two bases. Base one.
Base one times the height.
Base one
Plus base two.
So you're gonna add the
Plus
bases
base 2
Times the height.
times the height.
and then like.
And then you do times what? Is it 1/2?
You divide by 2 or
Oh, boy, let's go,
times
baby.
1/2. Yes. So if you like broke this up into a rectangle and a triangle and you added those together, this would basically give you your formula for trapezoid. So you may want to write that down. The area of a trapezoid is 1/2. The sum of the bases. Which two sides are the bases? The ones that are parallel to each other are the bases. And then what's the height?
From base one.
From base one to base two.
It's the distance between the two bases is your height, right? So for a right trapezoid, the height is actually a side. For any other type of trapezoid, it's just the distance between the two bases, okay? So how does that bring us to what we're talking today about area? So we have a curve. And instead of picking points and drawing rectangles, which are going to be obviously an overestimate or underestimate, instead we're going to connect the 2 points and we're going to make a trapezoid. What kind of trapezoid is that? It's a right trapezoid. Only, why does that one look different than this one? It's sitting on its side, so the height is actually the base. And these two bases, those are the ones that are parallel to each other. Now, how would I figure out the length of each base if this function is called f? So if this is x1 and this is x2, what would the length of this base be? It would be f of x1. It would be the y value, right? And the base, this base? F of x2. So you plug your x's into your function. You got your y values. We're using those as the bases. Okay, you ready? All right, I would like you to please draw this curve. So draw this parabolic function. We don't really know what the x and y intercept are. That's okay. Go ahead and draw this picture. We're going to approximate the area from 2 to 10 using 4 trapezoids. So 2, 10. What's my delta x? 10 minus 2 is 8. Divided by 4 is 2. Yes, please draw the picture. Okay, so every 2, you're going to go 2, 4, 6, 8, stop at 10. Put nice big dots on your curve at 2, 4, 6, 8, and 10. You guys know that if we have 4 rectangles, or in this case 4 trapezoids, you will have 5 x's. So take a moment to draw those trapezoids. You are connecting these points on the curve, and that gives you the trapezoid shape. So before I tell you the trapezoid rule formula, we are just going to calculate the areas of these 4 trapezoids and add them together and see if we can derive the formula. What? Trapezoids. All right, so we know the area of a trapezoid is 1/2 times the height times base 1 plus base 2. The height, all these trapezoids are on their side, so the height right here is the delta x. The height is the delta x. So what's the height of every one of these trapezoids? 2. So we calculate delta x the same way, b minus a over a. All right, now I'm going to color code these. So I have each trapezoid is a different color. So the first trapezoid I'm going to do in red. So the area of trapezoid 1, let's calculate the area of trapezoid 1. So it's going to be 1/2. The height is 2. Again, it's on its side. That's my delta x. Then I need base 1 plus base 2. So this length right here, that's my base 1. How long is base 1 if the name of this function is f? I'm going to put an f of x right here. Sorry, say again? F of 2. So I'm going to take that first x value, that a, plug it into my function. That would give me the length of base 1. Does that make sense? It's the y value. Okay. What's the length of base 2 right here? F of 4 would be that y value. Okay. So do we all agree that would be the area of that first red trapezoid? 1/2 times 2, the sum of the bases. Okay. We don't know what f is right now, and that's okay. It doesn't really matter. All right, trapezoid 2, I'm going to color in blue. Okay, that rhymed. Trapezoid 2. So, area of trapezoid 2 would be 1/2. H is still 2. What is base 1 for trapezoid 2? Base 1 for trapezoid 2. F of 4?
Yeah.
I'm not gaslighting anybody. Haven't we already used f of 4? Why am I using f of 4? I've already used it.
Because
Part of your base.
Okay, it's the same. It's still part of the base.
Don't tell me to look at it. I know. I'm trying to get you to figure it out.
We're finding separate.
You're finding separate
It's
areas.
base 1
and that is
of
part of our area.
trapezoid 2.
Is a part of base 2.
But it's also, we've already used f of 4. I'm saying, how am I using f of 4 again? I've already used it.
Because it's
gonna
base
be the
1
base
of
one of
another
this
Base
trapezoid.
one of another
Trapezoids are touching.
Yes, the trapezoids are side by side,
I mean, yeah.
meaning they do what? What are these two trapezoids doing?
They are together. So
They share. What do they share?
They share a base.
They share a side. They share a base. Right, so this is base 2 of the first trapezoid, but this is base 1 of the second trapezoid, right? Okay, plus base 2 of trapezoid 2 is f of 6. All right, trapezoid 3 I'm going to do in green. Sorry, this is a little bit hard to see. There's number 3. The area would be 1/2 times 2. I'm sorry, I probably should pick a better green. Base 1 of trapezoid 3 would be f of 6. Base 2 would be f of 8. And then the fourth trapezoid I will color in black.
You should do white.
That's better. 1/2 times 2. And then my bases here are the y values at 8 and 10. So f of 8 plus f of 10. Okay. So now what I would like you to do is we're going to total that area up. Let me get pink. I want you to add this, plus this, plus this, plus this. Add the areas of those 4 trapezoids together. What can I factor out of all 4? I can factor out the 1/2 out of all 4. What else? I can factor the 2 out because the height of every trapezoid is the same. And then I just need to add all of those heights together. I understand that we can simplify it. I just want you to see where the formula comes from. So we're going to add f of 2 plus f of 4 plus f of 4 plus f of 6 plus f of 6 plus f of 8 plus f of 8 plus f of 10. Do I need to write those all out separately?
No.
You can need to.
F of 2 plus 2 f
How many f of 2's do I have?
of 1.
I only have one. Why? Why do I only have one f of 2?
There's only one.
Because that base does not share side with any trapezoid, right? It's the end. So we only have one of them. Which ones will we have two of?
4, 6, 8.
4, 6, 8 are the what? The ones in the middle. Yes, all of the sides that are shared are the ones in the middle. So what we can do is we can write plus 2, and then all of the sides in the middle were f of 4, f of 6, and f of 8. So you can write 2, 2, 2 if you want, or you can just factor the 2 out of all of those middle bases. And then, of course, we only have one f of 10 because that is also on the end. It's just on the other end, right? So the two bases on the very ends, you only have one. They don't share any sides. All the ones in the middle, you have two of. Okay? So for this problem, would this area that we calculated be an overestimate or an underestimate?
Under.
Under. How can you tell? So here's the curve, right? And the trapezoid is a little bit underneath. Is that why? What is the curve doing that's making these trapezoids give us an underestimate? It is concave down. So it doesn't have to do with increasing or decreasing. It has to do now with the concavity. Because this curve is concave down, those trapezoids, look, they're going to be an underestimate. Okay? What if your curve was concave up? Then it's going to stick out above and be an overestimate. Okay, so here is your formula for the area of, for the trapezoid rule. So please take a moment and copy down that whole formula and write down the little notations in there. Take a second to write down this whole formula and copy down all those notations. Put a big box around it or highlight it, something to draw attention to that rule so you can find it later.
Can I get
Sure. But you need a pass to walk out of class. It's very good. Did you already write it down?
Yep. What is that? Oh, strawberries.
Strawberry pizza. We're missing 27. No, we're missing 3 people, but this person is here. Did someone sit there? Oh yeah, I got him. Bless you, student. Maybe I just can't count. I just can't count. All right, so we do want to memorize this formula. The area is going to be 1/2. That's from the area of a trapezoid. Your height is just going to be your delta x. So if you want to just remember delta x, we calculate delta x the same way. And then here are all of your bases. Notice that we only have one of the first base and one of the last base. So right here, I could also write f of what? What's my first x value? on my interval, what's my first x value?
2.
A?
Oh.
For like any interval, this would be f of a. What would this be? This is f of b. And then right here you have 2 of every base in the middle. Okay, so like this x would be a plus delta x, whatever that is. And then you keep adding your delta x until you get all the way to b. But if you want, you can list the 2 separately, or you can factor the 2's out of all of them. Okay? All right, here we go. I would like you to estimate the area under this curve from 1 to 3 using 4 trapezoids. So start by writing down the integral. The integral of 4 minus x quantity squared. Your bounds are 1 to 3. And we are using 4 trapezoids, 4 subintervals. So what should we calculate first? You need your delta x. So write down the problem. N is 4. Start with our delta x. Delta x is going to equal b minus a divided by n. 2 divided by 4 is 1/2. Now, before you start plugging into the formula, what I would recommend is you write out all your x's. I kind of just like draw a number line so I can see what all my x's are. Okay, so my number line is going to go from 1 to 3. That's a weird looking 1. Sorry, 1 to 3. 4 subintervals. So I break that up into 4 equal pieces. My delta x is 1/2, so you just add 1/2 to get the next one. So we've got 1. Of course, 2's in the middle. What's this one? 1.5 or 3/2. 2.5 or 5/2. I'm going to use fractions for this because it's a little bit easier to square fractions than decimals. All right, so if you do your little number line, then you can just pull those numbers as we set up our formula. Here we go. A equals 1/2. Always start with 1/2 times, what's my height or my delta x?
1/2.
Also 1/2. Please do not write 1/4. I want to see the 1/2 and the 1/2 because it is just a coincidence that our delta x is 1/2 for this first example. It's not always going to be 1/2. So I want to see every part of the formula. Times f of 1. So I have 1 of the first base. I have 1 of these. I have 1 of these, and I have 2 of all in the middle. Plus 2 times, and I'm just going to use a bracket for all of my bases in the middle. So f of 3/2, f of 2, and f of 5/2 are all the bases in the middle. So I have 2 of each of those. So I just pulled the 2 out. And then I have 1 of the last base, which is f of 3. So I actually want you to start the problem that way. Before you start plugging in y values, I just want you to write it in terms of f. So that I can see, like when you're doing this on your next quiz, do you have the correct x's in there? Okay? Questions on setting that up? All right, let's go. Let's plug and chug. 1/2 times 1/2. 1/4. What's f of 1? You're plugging it into this function right here. 4 minus 1 is 3 squared is 9. Plus 2 times 4 minus 3/2. Look alive, everyone. 8/2 minus 3/2 is 5/2 squared is 25 over 4. F of 2 is easy. 4 minus 2 is 2 squared is 4. F of 5/2, 8/2 minus 5/2 is 3/2. 3/2 squared is 9/4. Okay, see, it's not too bad when you're doing the fractions. What's f of 3? Uno. Guess what? For those of you taking the AP test, this is an acceptable answer. on the AP test, when you're doing free response questions, you don't have to simplify your answers. Raise your hand if you're taking the AP test. Anybody here? Yeah, so this is a time-saving technique that I'm going to, stress as we get closer to the test. As long as someone could type it in the calculator and press enter and get the exact answer, you don't have to simplify it. You just can't leave like function notations in your answer. But if like this would be a correct answer. Now, for our purposes, we are going to simplify it because I want to know what that equals. And if it was a multiple choice question, of course, those answers would be simplified. But for free response, you don't have to simplify it, which is kind of nice. Okay. Now you notice the ones that are fractions already have a common denominator, so that's kind of nice. How do you guys want to work this? Do you want to add these together? Do you want to distribute the two?
Let's add. Calculate.
Your brain is a calculator.
Not today.
Not today. Why don't we do that? 9 plus, that's 50 over 25 over 2, plus 8, plus 9 over 2, plus 1. I distributed the 2. So look, 9 plus 8 plus 1, that's 18. 25 halves plus 9 halves. 17. 34 halves. 34 halves is 17. There you go. We're almost there. 18 plus 17 is 35. Divided by 4 is 35 over 4. So 35 over 4 is an acceptable way to write that answer. What would that be as a mixed fraction? How many 4s go into 35? Or how many times? 8 and 3/4 as a decimal. 8.75. Those are all exact, guys. I will accept any of those forms, improper fraction, mixed fraction, or decimal, as long as they're exact. And then in the question, it does say estimate the area. So what's my unit? Units squared. Very good. Okay. Now, question. Is that an underestimate or an overestimate?
Under.
Well, you need to think about what does that function look like? 4 minus x squared.
Oh wait, is it?
Oh, wouldn't that be over?
4 minus x squared. Well, I need to know if this is concave up or concave down.
Down.
What does this look like?
Down.
What makes you think it's going down? There's not a negative in the front.
Oh, you do square it. Okay, so yeah.
The negative is on the inside, right? This is the same as negative x plus 4, which is squared, which is the same as the opposite of x minus 4, quantity squared. That's a horizontal reflection. And when you reflect a parabola horizontally, nothing happens. And then that's going to shift to the right. So that looks like that. It's concave up. So if I draw trapezoids, what's it going to be? It's going to be an overestimate. Concave up, the trapezoid is going to stick out over. Okay, how can we calculate the exact area under that curve without doing a limit? Okay, let's use FTC. I would like you to use FTC to calculate the exact area under that curve so we can prove that what we just found was an overestimate. Okay, so how do we do FTC? Fundamental theorem of calculus. So you're going to take the antiderivative, and then you're going to plug your bounds in and subtract your two values. So I would like to avoid using U substitution. What can I do so they don't have to use U substitution? You can square it, but half of the people that took the quiz yesterday couldn't square a binomial. So maybe this is good practice for us. What is 4 minus x quantity squared? Yeah, there's a middle term. Okay, 4 times 4 is 16. 4 times negative x is negative 4x. Times 2 is negative 8x. Negative x times negative x is plus x squared. That's what it looks like when you square something. You get a trinomial when you square a binomial. Yeah, no, half of the groups couldn't square a binomial yesterday, which makes me very sad. Okay, go ahead and find the antiderivative of that, please. Everyone, in your notes, find the antiderivative of each of those terms. You can use the reverse power rule. Use the reverse power rule. Some of you need to sit up a little bit more, help yourself stays awake. Okay, what is the antiderivative? Okay, you don't need the c, that's right. 16x minus 4x squared plus 1/3 x cubed. Why don't we need the c?
Because they can't.
That's correct. When you are doing a definite integral and you subtract, the c's always cancel, so you don't need to put the c at all. Okay? So we are going to substitute the 3 in first, and then substitute the 1 and subtract those two. Thank you. This is for your dentist appointment. It's going to take the rest of the day. You could come back at 2:40.
Well, what's the 11:15?
Yeah. I know the dentist is not going to take that one. All right, so we start by plugging in a 3 for the x. 16 times 3 minus 4 times 3 squared plus 1/3 times 3 cubed. Then we're going to substitute in the 1, and we're going to subtract. Because we're subtracting, you have to put the second expression in parentheses. That negative is going to distribute to everything. So plug in a 1, 16 times 1, 4 times 1 squared, 1/3 times 1 cubed. It doesn't matter if you use parentheses or brackets. All right, let's see who's big brain with the math. 16 times 3? 48. Minus 4 times 3 squared? 36. 1/3 of 3 cubed? 27 divided by 3 is 9, right? Right? Minus 16, 4, and 1/3. But look, the negative applies to all 3 of those. Final answer. Ooh. Why is the 3rd there? Because you know that the exact area is not going to be like a pretty integer most of the time. It's not going to be a pretty integer. 48 minus 36 is 12 plus 9. 21 minus 16. 5.
1
plus 4. 9. So the answer is 9 minus 1/3. And you can write your answer as 8 and 2/3. Or you can write your answer as 26/3. Which is, I'm just writing this so we can compare it to our trapezoidal approximation. Our trapezoidal approximation was 8.75. We said that was an overestimate. The actual area 8.6. So it really wasn't that big of an overestimate. So any of these answers are acceptable. Any of those answers are acceptable. This is the type of thing that you'll have to do in your next homework. Your next homework is in my math lab. It's not due until Thursday. So you have 2 days to do it. I do ask that you start it tonight so that if there are any issues or any like weird questions, you can tell me about it tomorrow before it's due on Thursday. Okay? All right, we got a sticker question. And you can use your calculator for the sticker question. I want you to estimate the area under x cubed from 0 to 2 using 8 trapezoids. 8 trapezoids. So, this is example 2. Integral of x cubed from 0 to 2. I don't know if you're going to be able to finish it in time, but today's flavors are pizza and strawberry.
Oh, that's why you were saying pizza, strawberry.
Strawberry pizza. Yeah, has anyone ever had strawberries on? People eat pineapple in their pizza. Is there strawberries on their pizza?
Different.
Is it though?
Yes.
I think it might be.
Yeah. It is.
Even then, it's still exotic.
I might put strawberries on my pizza if I had like pecans, blue cheese,
If it was like straight
balsamic
cheese,
drizzle.
I could put on.
Yeah, that would be good. Alright, start by finding your delta x. Delta x equals 2 minus 0 divided by 8. 1/4.
Let's do it together, everybody.
Maybe. We can hurry. Alright, draw your number line. We're going from 0 to 2. Guess what? Boop, 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 boop. 8 divided into 8 equals subintervals. Of course, 1's in the middle. Here's a half. Here's 3/4. That's not 3/4. 3/2. This is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 2 is 8/4. There you go. So if you list out all your x's, then it's going to be a little bit easier when you go to plug those in. All right, so the area using the trapezoid rule is going to equal 1/2 times 1/4 times, we only need one of the first base, so f of what?
0.
F of 0. Plus we need 2 of all the middle bases. How many middle bases do I have? 1, 2, 3, 4, 5, 6, 7 middle bases, 2 end bases, right?
Yep.
You should have 9 x's for 8 trapezoids. Okay, so plus 2 times right? All right, we got 2 of all the middle bases, 1/4, 1/2, 3/4, 1, 5/4, 3/2, 7/4, plus we have only one little f of 2 at the end. Now, if you type this into your calculator, we can work smarter, not harder. Go to y equals. Go to y equals. I'll put this back up in a second. If you go to y equals, I want you to type in x cubed, so just whatever function you have. I want you to go to mode and make sure that you're on fraction mode. Then you're going to go to your table set. Table setup is right here, so second, table set.
Where do you see fraction mode?
You go to mode, scroll up or down, doesn't matter. It says answers, auto, decimal, fraction.
Oh, okay.
No.
So this will put all your answers in fractions. Now go to your table setup. We're going to start at 0, and we want our delta x to be 1/4. If you automatically set up the table, hey look, here's all your y's that you can just pull from here. You can just pull them all from here, from 0 to 2.
Oh wait, it says fraction.
So I'm pulling all those fractions, and I'm plugging them into there. Okay? So I would like you to try finishing that to see what you get, and then I also want you to check what is the actual area under the curve using FTC, so you can compare those two things. Okay?